Hello everyone and happy Friday. We are about 1 week away from spring break, your first college spring break, so exciting times ahead. But a lot of things happening before we leave for break and a lot of work to get done as well. First off, I'm going to get out of the way and show you that we have a workshop set aside for students in the TI lab this Friday. The STEEL Club, the Society for Themed Entertainment Engineers and Leaders, awesome club. You know, they're the ones that build the really cool small-scale themed rides and whatnot. It's just a great organization for those of you interested in that field of study. But they're holding a workshop because they want to do some outreach, and they thought, hey, we've built boats before, we've built lots of other things as well, and so they are going to be there from 6 to 8 this day, tonight, March 6th, to help all of you out. So come with your team, come as an individual, come with questions, come with materials if you want to, actually just kind of work on your boat, start working on your boat. Hopefully everybody is working on their hulls because we definitely need that to happen. Reminder again, the career mixer is coming up for the CECE department. If you're not a civil environmental or construction engineering major, that's okay. You can still go and attend and see if they need any other types of interns. But if you are CECE, I just implore you have to go because it's an opportunity to just walk around, talk to people. These are the people that you'll be working with in the future. These are the projects, what they're doing. Ask them what projects they've got going on. And you're going to find out so much more about your major. And as always, make sure that this is what you want. Okay, the Internship Expo is coming up next week as well. Like I said, really busy week. There's a Know Before You Go article. Here's the link. I'll put this in web courses as well. Make sure you have your business attire, of course. They did make a big notice that avoid any kind of big bags, all right, because that's just going to slow things down because of security. So yeah, practice your elevator pitch. Get about 10 to 12 copies of your resume ready to go. And, good luck next week. Reminder again, the Burnett Honors College does have their second year entry opportunity. I want to remind students again, because some of you have come into the office and we've chatted, they really are looking for people that had an incredible first semester and a half here at UCF. 3.8, 3.9, 4.0. They're really looking for people that have handled the rigor of college academics, but they've also gotten involved. Again, it's a two-step process. You get vetted for application 1. When you pass that, then they reach out and give you application 2, and those are due on the 15th of April. Okay, one more reminder again, the deadline for the A20 scholarships is March 31st. Go ahead and apply within A20. Great Naval Orange Race, got a couple updates for you here. Reminder that all the teams need to purchase their batteries as well as their the LiPo battery safety bags. It's basically a fire hazard. It can become a fire hazard. And so if you've got this bag, then you simply put a battery that's swelling. They talked about this in lab, hopefully, but a battery that would be swelling indicates that something's not right, and it goes in the fire safety bag. Okay. Reminder or let you know, let's talk a little bit about what's happening next week. And the bottom line is that the CDR is next week. You need to make sure that you dress appropriately. Anytime you're going to do a presentation in front of someone, you want to dress as professionally. Don't look like you just rolled out of bed kind of thing, of course. We are going to be issuing also the motors and the servos for those of you that want them. Well, everybody needs them. Boat has to go forward, right? You need to, I don't know why it keeps slipping back like that. But the bottom line is that when we issue these parts to you, you have to return them at the end of the semester, all right? The servo, you'll have to return. This motor, you can see there's a motor mount there. Use that motor mount, use the screws, and that's how you're going to attach the motor onto your vessel. You are not going to use something like Gorilla Glue to the point where we are not able to get that motor back off of the boat and reuse it for next year's race. Okay, so we really are asking you to be very cognizant of not attaching these parts that must be returned in a manner that we can't get them back. All right. So just a kind of a warning there. Reminder too that if any of you are at the point where you're spray painting or decorating your hull, please don't do that on the concrete because it stains the concrete and our campus looks terrible. There's spray paint all over the place. It looks like graffiti, right? We need you to paint on the grass because that gets mowed and the rain clears it away as well. And then again, one more final reminder about the steel sponsored workshop for your boats. Please take advantage of that. And I hope we see a lot of people here. Okay, now today's presentation is a guest speaker from the University of Pittsburgh. And her name is Dr. Renee Clark, and she is an industrial engineer. So for those of you industrial people, here's someone in your realm. And she is part of an NSF, National Science Foundation study that is looking into a topic, and the topic is engineering judgment. That may seem like, well, what is that? Well, honestly, that's what her group is working to analyze and define. But really, engineering judgment is just something that is going to be built in you over time. All right, over time, your engineering judgment is going to become hopefully better and better and better based on all of your experiences. The decisions that you make, whether it be technical decisions or whether it be ethical decisions, your engineering judgment is something that we're talking about in this lecture because we want you to become aware of it. So again, very unique and interesting lecture today. The questions at the attendance at the end will be geared kind of toward Dr. Clark's research. So please, take them seriously and be sure to respond to them. And again, look forward hopefully to seeing some people tonight. Busy week ahead. Good luck, everybody.
Hi, I'm Renee Clark. I am from the University of Pittsburgh, Swanson School of Engineering, and I am a faculty member in our Industrial Engineering Department, and I'm going to talk to you today about engineering judgment. Let's define it, and let's talk about using it. So I'd like to start my talk today by posing a question to you. So I'd like to ask you, is engineering judgment important in professional practice? What do you think? Most people would agree, yes, it is, that it is an important competency, that it's critical to tasks that we as engineers do quite frequently, such as designing products and services, solving difficult problems, doing various analyses such as data analysis. Judgment, I would say, is definitely a uniquely human capability. Okay, so now I want to pose a second question to you, which might be a little bit more difficult to answer. This question is, how would you define engineering judgment? And this poses a little bit of an issue because without a definition, the question becomes, how do we assess students, for example, for the presence of engineering judgment? What types of educational materials do we provide on it? What types of education should we provide on engineering judgment? Okay, and we know engineering judgment intuitively is important. So besides that fact, ABET, our accrediting body, actually tells us that it's an expected outcome of students upon graduation. Okay, so I'm going to pose this same question again to you. Okay, how do you define engineering judgment? Okay, so I'd like you to take just a few seconds and jot down on a piece of paper what you think engineering judgment is. How would you define it? What ideas come to your mind when you hear the words engineering judgment? Okay, so if you could just take a few minutes and do that. So on a little piece of paper, just jot down. These are my ideas of engineering judgment. Okay, so when we went into the literature to search for these various concepts of engineering judgment, we came up with 14 main notions of engineering judgment in the literature that we used to inform our Delphi study. Okay, so these are the 14 items we found, and as I go down through them, ask yourself, Ooh, did I put this down on my piece of paper or on my card? Okay, so this is what the literature, the concepts of engineering judgment in the literature. The first is application of one's knowledge or experience. Engineering judgment is approximation. It's asking, is something reasonable? It's consideration of various contexts, such as societal contexts, ethical contexts, or cultural contexts, etc. When you are, for example, designing something or solving a problem. There's a notion of it in the literature of creativity, critical thinking, decision making, including weighing of issues. So, decision making in the midst of complexity. It's being able to identify important versus non-important details, including defining the right problem. It's being able to foresee potential problems. It's making assumptions when necessary, for example, to simplify a problem or to be able to solve a problem. Okay. It's being able to recognize mistakes or errors in one's work, including through testing. It's being able to use feedback, constructive feedback, use and apply it. It's making use of tools or standards or codes of practice. And the 14th notion of it in the literature is that of it involves effective communication. Okay, so that's what's out there in the literature. Okay, so first question is, are any of these on your piece of paper or on your card? If so, great. And so this was the work of our Delphi panel, is to somehow try to take all these various concepts or notions and integrate them, come up with a definition that involves all of them. Okay, so on our Delphi panel, the 18 people that we had, they represented a wide range of disciplines, okay, so that we made sure to get diverse perspectives, right? Because engineering is a very broad area, okay? So on our panel, we had people from the following engineering disciplines. We had aerospace engineers, bioengineers, chemical engineers, civil, environmental, geotechnical, software engineers, electrical engineers, and mechanical engineers, okay? We also had some people on our panel who were not expressly engineers. Actually, we handpicked these people because they were some of the people that had contributed to that literature that I told you about. So we actually had people on the panel who were from secondary education, who specialized in English, who specialized in just engineering ed research, and we also had one person who focused on risk and safety. And in addition, we had 3 ABET evaluators on the panel because of the involvement of, or the association of engineering judgment with ABET in terms of it being a required outcome upon graduation. Okay, so what did the Delphi panel come up with in terms of a consensus definition for engineering judgment? Okay, so how did the panel define engineering judgment? Okay, at its core, what the panel found, or the Delphi study found, was that engineering judgment is actually a very simple process. Okay, it's composed of 3 main components. Okay, the first one is you, right, the engineer or professional. The second main component is the situational context, and what we mean by that is the factors or the conditions that might surround a given problem that you're trying to solve, or design that you're trying to make, or analysis that you're trying to do, okay? And the third main element is critical thinking, okay? Okay, so this is a very abstracted visual model of the definition of engineering judgment that the panel was able to come up with. So it's very abstracted at this point, okay? So what this model is saying is that, first, engineering judgment is a process that's initiated by some sort of opportunity or problem that you're trying to solve. Think of an opportunity as some sort of a design need, okay? So the process is driven, the engineering judgment process is driven by something that you need to solve or something that you need to do that's perhaps rather somewhat complex, okay? Now, the Boxes that are contained within the light blue boxed area here, those are the components that actually comprise the engineering judgment process, okay? And there are those three main components that I told you about, right? You, the engineer professional, the situational context, and there's the critical thinking, okay? So the way to read this is the following, okay? The engineer or the professional applies or incorporates certain knowledge or traits or features in an ongoing way to perform critical thinking, while at the same time considering various situational context factors or issues also to perform critical thinking. So those hatched arrows mean that you are, as the engineer, you're continuously applying or incorporating or continuously considering different situational context factors as you're performing critical thinking, okay? Now, a large component or a subcomponent of critical thinking is evaluation, okay? Now, what I also want you to notice is this thick blue arrow that goes from critical thinking back to the engineer professional, okay? So what we think is going on as part of the engineering judgment process is that there's a learning loop as well, a formative loop that says that as you, as the engineer, performs critical thinking and, the results of that critical thinking undergo evaluation, you are at the same time learning, okay? You are building on your knowledge and your experience, and there's a formative impact that's occurring, okay? So, the output of all of that at the end is some sort of a culminating decision or solution that results or that is made out of the engineering judgment process, right? Now, we believe judgment develops over years, right? And this is, in part depicted by that feedback arrow, right? Certainly in as a undergraduate, you will begin to learn engineering judgment and you will begin to exercise engineering judgment, but it's really something that develops over years, okay? And again, as is captured in that feedback loop. Okay, so that's our fairly simple or abstracted process of what engineering judgment is. When you actually go to apply it in the real world, it actually becomes a lot more complex, detailed process that we think looks like this, okay? So this is a more, what should say, fleshed out definition or model, a less abstract version of what I just showed you, but it still has all the main components. It just has more detail, right? It still has the driving opportunity or problem. It still has the culminating or final decision or solution that comes out of your engineering judgment deliberations, okay? Still has the engineer or a professional as one of the main components. There's the situational context. Here's the critical thinking with the evaluation as being a major subcomponent of that. Here's the arrow that shows you're going to apply certain features as an engineer or consider parts of the situational context. And then there's that formative impact learning loop. Okay, so it's all there. This model just shows a lot more detail, right? Because when you go to apply it in the real world, things are more complex, right? So I know this is overwhelming to look at it first, but I'm actually going to step you through each of those main components and then for example, the yellow boxes that you see or the subcomponents of the engineer professional, and then we'll bring it all back together. Okay, so let's walk through more of the detail. Let's start with the situational context and what that looks like at the more detailed level. Okay, so the situational context, remember, are the factors, the issues that surround a problem or a design opportunity, okay? So these are the 10 factors that we've been able to come up with thus far that comprise the situational subtext that an engineer should be considering when they're doing critical thinking, right? We have, just for organizational purposes, kind of roughly grouped them into people factors, or factors that are sort of more specific to people, versus factors that may be more specific to a product or a process. Okay, so what are some of these situational context factors that may be more related to people? Okay, so certainly when you are designing something or solving a problem, there are societal or social factors that you should be taking into consideration, right? There are cultural or global factors. Okay, there are ethical factors, right? There may be health and safety factors. There may be aesthetic factors. Okay, so over into the product process factors. Now, again, not all of these may apply to any given problem, but given what you're doing at the time, aesthetic factors may play in. For example, if you're designing a car, right? Certainly aesthetic factors play a role. There may be economic factors you have to take into consideration, environmental factors, right? Okay. Uncertainty may play a role, taking into consideration or into account what you don't know, right, or unknowns that exist, including risk. Constraints always play a role with engineering judgment. Cost constraints, right, time constraints, other resources, regulations certainly play a role. Things such as Federal Communications Regulations or FAA regulations. Okay, and then the final situational context factor is complexity, right? Being able to consider the complexity of your problem or what you're trying to design. Okay, and complexity is driven by when you've got competing issues or trade-offs that you have to weigh, right? Or the fact that a lot of variables and factors are interdependent. So when you impact one, you impact the other. Okay, even just the dynamics or the politics of an organization that you may be working in, okay, contributes to the complexity of, the problem you may be trying to solve or the design you may be trying to accomplish. Okay, so just to talk about the situational context a little bit more, these are some examples from Dr. Dickerson's junior design class, which is a class for electrical and computer engineering juniors at the University of Pittsburgh. And these were some examples of various situational context factors that he talked to his students about when he gave this presentation to them. So remember that these are ECE students. So these examples would be a little bit more specific to electrical and computer engineering projects. But for example, there are FCC regulations, right? Federal communications regulations, for example, when you are designing wireless devices, okay? They represent a constraint, right? That you have to work with, that you have to consider as part of a design, okay? As an example of a cultural factor may be if you're a software engineer and you're designing a video game, you may need to adapt that video game or the storyline within that video game to various norms or interests of the country in which you're going to be marketing that video game, right? How about when you're designing a user interface? You do need to absolutely design with your audience in mind, with your people in mind, okay? So you might consider that a societal factor. Okay, an environmental factor. Electronic waste is a large global problem, right? Old iPads, old phones. What do you do with these? So perhaps when you are designing the next generation, you might want to consider minimizing. How can I go about minimizing future electronic waste, right? Aesthetic factors, as I said, if you're designing a car or perhaps a toy, for a child, certainly it has to look good, right? You have to consider aesthetics. And finally, a good health and safety factor, a good health and safety example would be that of trying to consider, should I use lead versus non-lead based solder? So there are health and safety concerns with lead, but there are benefits to and drawbacks to each of these. So it's a consideration that you have to take into account, if you need to use the soldering process. Okay. Okay. So let's flesh out then. We just talked about the situational context. Let's flesh out a little bit more the traits and the features that you as the engineer or the professional bring to the engineering judgment process. Okay, so what do you bring? Well, actually, you bring a lot. These are the things you bring and that you should apply or incorporate as part of the engineering judgment process. Okay, so first of all, you bring a lot of explicit knowledge. So what do we mean by explicit knowledge? Okay, we mean knowledge that's documented, right? So things that you may be learning in your coursework, right? Academic knowledge. Data that you may collect or have access to. Various forms of media that you may read or access. Standards and codes. Okay, so for example, IEEE, which is the Institute for Electronic and Electrical Engineers, has, for example, Code 754, which discusses floating point division. Okay, so various standards and codes that we have to be aware of and use as engineers. Perhaps various skill sets that you bring, how to program a computer, how to use computer-aided design, how to use simulation software, certain skill sets. Okay, so those types of things represent your explicit knowledge that tends to be documented. Okay, so knowledge that tends to be less documented or perhaps even less documentable is what we refer to as tacit knowledge. Okay, this is knowledge that, for example, tends to be based on experience, right? Or intuition that you might have, often which is driven by experience, right? And that, kind of just this facet in and of itself gets at, why we think engineering judgment develops over time, right? You have to build your experience as an engineer in order for your engineering judgment to really grow and get really sharp. Okay, so what else do you as an engineer bring? Well, you bring what's known as metacognition. I don't know if you've ever heard this term before, but what metacognition is, meta means sitting above. Okay, so metacognition is just thinking about your own thinking or your own behavior, okay? And so when you think about your own thinking or your own behavior, you tend to drive a lot of self-awareness, right? And so you do this by reflecting, right? Doing a lot of reflecting. Metacognition also involves what's known as self-regulation. What do we mean by self-regulation? That essentially means your ability to manage yourself, manage your behavior, manage your learning, right? Things such as your ability to plan things, plan for your learning, the ability to monitor yourself, monitor your progress, monitor your work. Am I doing well? Am I doing what I need to be doing? And then the final part of self-regulation is evaluating oneself after the fact, right? Okay, so metacognition tends to be a behavioral-based trait or quality that you as the engineer bring to the engineering judgment process or should bring to that process, okay? And then finally, you bring your identity to the engineering judgment process, right? So initially, you might say, what in the world does my identity have to do with engineering judgment, okay? And a lot of people say that at first, but this notion tends to grow on you. What we mean here by your identity are things like your values, your character, your morals. These most certainly play into the engineering judgment process. Your interests, your self-efficacy. Do you know what we mean by self-efficacy? What we mean by that is your belief in your ability to be successful at something. So it has to do a lot with your self-confidence, okay? So those are the aspects of your identity that we believe are most important to the engineering judgment process. Okay, so these are the four main things that you as a professional or engineer bring to the process. Your explicit knowledge, your tacit knowledge, your metacognition, meaning your self-awareness, your behavior in terms of being able to plan, monitor yourself, self-evaluate, and your identity, okay? These are all incorporated or applied in the process as part of the critical thinking. Okay, so we covered that. We just covered that. Let's talk about what is involved in critical thinking. Okay, this is what we believe comprises the critical thinking process. Okay, remember, critical thinking has a big subcomponent to it, evaluation. That sits over there. Okay, so this is what we think critical thinking is, or what should be done during critical thinking as part of the engineering judgment process. Okay, first, you have to define the problem or goal that you're trying to accomplish or that you're trying to solve, right? Defining that right problem. What is it that I really need to do? Okay, and that's not easy to whittle that down as to what you at times really need to do. Okay, now once you do that, you can begin to identify solutions. All right, which may involve various modeling techniques. Maybe you are going to simulate your solution. You're going to prototype it. Certainly as part of that, at times you have to approximate various things to get to a solution. You may need to make some assumptions. Okay. Once you identify various solutions, you make a decision on the one you want to go with. Right. Now, it doesn't just stop there, right? These 3 steps should always be evaluated, and it actually should be somewhat of an iterative back and forth process. So, as you begin to define the problem, identify solutions, and then perhaps make a decision, you should be evaluating each and every one of those, okay? Meaning you should be doing testing, okay? You should be critiquing your work, looking for errors, actively looking for errors. You should be trying to foresee problems, okay? Look into how a solution may impact something down the line, okay? And certainly, as part of the evaluation, you should be seeking feedback from others. You should be communicating with others about what you're doing, okay? So it should be an iterative back and forth of these steps being evaluated, okay? That's what we think is involved in the critical thinking process. Okay, so bringing it all back together then, okay? We think that good engineering judgment happens over time, right? I think our goal here is to begin to get you to think about what comprises good engineering judgment and to begin to develop those skills. And we want to begin to assess you in those skills. But really, engineering judgment develops over time. And as you exercise engineering judgment and as you evaluate what you're doing and you get feedback, there's going to be learning that's occurring over time. There's going to be a formative impact to you, and it's going to alter your knowledge. It's going to grow your knowledge, your explicit knowledge. It's going to grow your experience and your intuition. It's probably going to begin to, perhaps change some things about your professional identity, okay? And hopefully it will enhance your self-regulation, okay? So there's going to be a feedback loop. So I wanted to thank you today for listening to this talk and considering engineering judgment and what we've been able to come up with it. I wanted to again acknowledge the National Science Foundation and thank them for their support of our work, and it was supported under Grant 234-8089. If you have questions about this or would like to otherwise talk to me, I am again Renee Clark. From the University of Pittsburgh Swanson School of Engineering, and this is my email address, rmclark@pitt.edu. I would welcome any questions you have, and thank you for your time and attention to this.
Hey, welcome back everyone to another segment of TA Spotlight, and I'm here with TA Landon this week.
Hi, y'all.
And in particular, this week we heard from Dr. Renee Clark from the University of Pittsburgh about her work with defining engineering judgment, which is a pretty hard topic. So I want to pose this question to you, Landon. What is engineering judgment to you?
Engineering judgment to me, it's like taking your entire engineering background, all your engineering knowledge, all the technical knowledge, putting yourself into a situation or having you put into a situation, and then using both the context of that situation and your knowledge to make a decision in an engineering field. That's what I think.
Absolutely. I mean, ultimately, it comes down to making a decision. And as engineers, we have to make lots of decisions, whether it's about the design of a product or whether or not you should purchase something. It's definitely a multifaceted concept. I know for me, it has to do a lot with like the ethics of your decision.
Yeah.
Also, just like that hard to define gray area of using creativity and your own experience to decide if a decision is good or bad. It's really hard to pin down.
Yeah, I know in electrical it's like more foolproofing. Like what can we do to foolproof this design a little bit more, because we're messing around with higher voltages or delicate components. So how can we make it so that it's not easily broken or someone easily isn't getting hurt?
Yeah, that's a great suggestion. Yeah. Very important as well.
Yeah.
So Landon, we've kind of given some initial thoughts on what engineering judgment is, but part of the reason it's so hard to define is because it's so broad. So one thing that really helps me is thinking about it in terms of like concrete examples.
Yeah.
Like really applying the judgment to engineering projects. Like at the end of the day, that's what matters. I know for me, I didn't really have to exercise a whole lot of engineering judgment until I started doing projects. And one big one was senior design. And just to give a little bit of background knowledge, my senior design project, we made an automated spice dispenser. So we had to deal with food safety. So these spices that we're putting in our machine have to stay safe and intact until they get delivered to the user. And one really big thing was our containers. Do we buy them pre-made or do we manufacture our own? And that wasn't just like a clear black and white decision. We kind of had to use our own judgment, not only as engineers but as humans. And what is going to preserve the spice as well? What is going to give like a smooth user experience in the machine, but also like on a material science level, what is going to keep these intact? Yeah. So I think that's one thing that really like for the first time clicked with me, like, oh, some of these decisions you just as a person have to rely on your experience with. Do you have anything that sort of helps with you?
Yeah, I mean, I can even talk as a TA if a team comes up to me with a more complex design and says, hey Landon, do you think this design could work? I could look at it and say, theoretically, yes, you could build a boat like this if you were given this amount of time and this resources and this budget and all of this. But the team itself, which is the situation, the context of the situation, the team itself may not have the skills to complete that boat design, which I think is a really tough decision to make as a TA. Do you recommend that they do it? Do you not recommend that they do it? Because they could sink hours into this boat design only for them to fail on it or something not work or anything like that. And that kind of then becomes on you, like, hey, I did recommend that team do that. So we as TAs have to use our own situational awareness and our engineering background and experience to help teams and guide them along to the path of success.
Yeah, that's a great point.
We can talk about engineering, but we can also talk about my job, which is refereeing. I use that all the time where I have a certain situation where do I go yellow card, do I go red card, do I call a foul, do I not call a foul? It varies by game. I have to understand the feel of the game. I have to understand the temperature of the game. All right, do I call a foul here in U19 boys or do I call a foul here in U12? It's very, very interesting to talk about judgment like this.
So the last thing that I want to discuss with engineering judgment is the fact that the Great Naval Orange Race is actually a really good opportunity for our students to begin building their judgment skills. This is a project that lasts multiple months where they're working with teammates, where they're making decisions on a daily basis about what parts to get, what kind of design they're going to go with. So this is something that not only offers them the ability to maybe learn from their mistakes, but also to incorporate that into the future for their future projects and their career ultimately as engineers.
Yeah.
So
this is that time where they start building up sort of who they are as engineers and start building up their knowledge in both the factual engineering basis and the contextual basis of like, okay, this is how I know I'm going to handle this situation in this context. I mean, I've had to talk to some students about like, getting more reliable parts, more reliable brand parts versus maybe some bootleg parts.
yeah, that's
From,
true.
having discussions about AliExpress versus Amazon. It's like, you got to make your best judgment there in the situation of, hey, we have, 4 weeks to race? 5? And do we want to start ordering parts from AliExpress?
Yeah.
And the other things of like, how are we going to slice our 3D design? It's because you can't just like start magically 3D printing your entire hull. It's going to take some time to figure out how to slice it, how you're going to space out the parts, how it's going to all actually work in a manufacturing process.
Yeah,
So
totally.
that's points where you can use your engineering judgment to make those decisions.
Absolutely. Well, thank you for all your expertise and for giving us your thoughts on engineering judgment this week, Landon. So we're going to end the TA Spotlight here. Thank you guys for your attention, and I'll see you guys next week.
Bye, everyone.
Hi everyone, and welcome back to Go for Launch with the GTAs. We're going to start off here with our weekly timeline. So we are now on week 8. We are closely approaching that race day. And this week you should have gotten a little bit of an introduction to your guidance systems, as well as made those waterproof boxes if you took them from us at least. And next week is going to be your CDR presentation, where your whole group is going to present your project thus far, and you will also be given motors and servos if your heart desires. Make sure for these CDRs that you're practicing prior with your team so you understand what you have to present, and also make sure you're in either that business casual or your team themed attire to make sure you get those points.
All right, your lab TA should have also assigned the lane that you're going to be racing in. If you haven't received your lane yet, they're going to go ahead and let you know next week as soon as they can. Something else to keep in mind, those holes are going to be due when you get back from spring break, so make sure you're working on those ahead of time. If you want to have more free time over break, I'd recommend getting them done before.
Thank you. And this is everyone's final reminder that tonight from 6 to 8 p.m. in the atrium, Steel is hosting a Great Nouveau Orange Race workshop where some Steel members and some TAs are going to be there to help you guys out as we approach a pretty critical phase of the Great Naval Orange Race where you guys are making decisions about your hull design and other things like that. So keep an eye out. We're there to answer questions and help with manufacturing. Thanks, and let's move on to the quiz code for today.